Some wars are fought with boots and bullets, but the next one? It might be fought by machines that don't sleep, don't flinch, and don't miss. Just recently, Russia rolled out military robots that stunned global analysts, including some in Washington and Beijing. From mine-clearing beasts to AI-powered assault units, these machines have stepped out of the realm of concept and into reality. They're tested and ready. In this video, we're breaking down the newest combat robots changing the rules of modern warfare. Let's begin with the Iran 6, Russia's dedicated demining robot. This 6-ton tracked machine is designed to do one critical job: clear out deadly explosives from the battlefield. It's built with rotating flails, heavy-duty rotors, and reinforced dozer blades that tear through terrain, unearthing and destroying mines buried beneath the surface. Whether it's the larger anti-tank charges or smaller anti-personnel mines, the Iran 6 is equipped to neutralize them all. What makes it especially effective is how it operates. It's controlled remotely, allowing soldiers to stay out of harm's way, while the machine handles dangerous tasks up front. Even in hostile zones, the robot keeps going, absorbing shock and continuing its mission despite nearby blasts or debris. But it's not only a combat tool. The Iran 6 has seen deployment in post-conflict areas, clearing mines in urban ruins and former battlegrounds. That dual role, military and humanitarian, makes it a valuable asset. It's also been used where traditional clearance methods would take too long or risk too many lives. Engineers continue to upgrade its systems, enabling the robot to identify newer types of IEDs and refine its clearance methods accordingly. The result is a robot that strengthens combat mobility and safeguards both troops and civilians in unpredictable environments. Now let's shift to a more versatile platform, Russia's Marker combat robot. Unlike the Iran 6, which serves a focused purpose, the Marker is designed for flexibility and real-time adaptability. At the core of its operation is a powerful AI system with advanced computer vision. The robot can scan surroundings, identify threats, and choose the safest or most effective route, all without constant human input. It can even command a swarm of kamikaze drones, turning it into a frontline coordinator for coordinated strikes. Thanks to its modular build, the Marker can be equipped with various payloads, ranging from traditional firearms to non-lethal crowd control tools. This makes it suitable for both military engagements and peacekeeping missions. The Marker has been field-tested in urban and open environments, proving its mobility and responsiveness under pressure. One of its standout features is the ability to distinguish allies from enemies, minimizing the risk of friendly fire. Russia aims to integrate the Marker into broader networks, connecting it with air drones and cyber systems to form a cohesive autonomous warfare unit. Next, let's turn to the Scorpion S-15, developed in Armenia. Compact and built for agility, this ground robot measures just 1.2 meters in length and weighs around 370 kilograms. Despite its small frame, it can reach speeds up to 40 kilometers per hour, making it ideal for rapid response in close quarters or difficult terrain. Its design emphasizes quick deployment, whether it's an urban alley, a forested trail, or a remote combat zone. The Scorpion S-15 size allows it to navigate areas larger vehicles simply can't access. But it's not just about mobility. This robot carries serious firepower. It can be outfitted with a machine gun or even a handheld RPG-7 launcher, providing ground troops with mobile support where it's needed most. For missions deemed too dangerous for soldiers to enter directly, the S-15 becomes a frontline asset, delivering combat capabilities while keeping human personnel out of harm's way. Its lightweight structure also simplifies transport and redeployment across zones, making it a flexible solution for fast-moving operations. With modularity in mind, future versions could include new tools or weapon setups depending on mission needs. Okay, moving from Armenia to Ukraine, we see a different approach with the Ironclad. Designed by Robotics, this wheeled robot fills multiple roles: combat, logistics, and even medical support. The Ironclad can haul up to 350 kilograms, whether it's carrying supplies, ammunition, or evacuating injured soldiers from active zones. Its mobility across rugged terrain makes it reliable in field conditions that are constantly changing. For protection, the Ironclad features armored plating to shield against shrapnel and small-caliber gunfire, increasing its durability under threat. It also carries integrated weapon systems, allowing it to engage in direct combat support when required. One of its standout capabilities is adaptability. Developers have plans for AI-powered pathfinding and thermal imaging for casualty detection. That means future models could independently locate wounded personnel and navigate to safety, all while under fire. This combination of transport, fire support, and real-time rescue makes the Ironclad a vital tool in Ukraine's forward operations. It's already proven its value by extending what troops can do without increasing their exposure to danger. Germany's contribution to robotic warfare comes in the form of the ACW Weasel, a compact, lightweight autonomous combat vehicle built with both speed and silence in mind. At its core is a reliable 81-kilowatt Volkswagen diesel engine. Chosen for its balance of power and efficiency, the Weasel's small footprint allows it to maneuver easily across varied terrain and be transported quickly by air if needed. Flexibility is built into its design. It can operate in 3 distinct modes: manual control, remote command via tablet, or full autonomy. This tri-mode system allows the robot to switch between human oversight and independent operation based on the demands of the mission, whether scouting ahead, delivering supplies under fire, or offering light fire support. It adapts with ease. One of the Weasel's standout features is its stealth. Its thermal and acoustic signatures are significantly lower than typical military vehicles, which makes it particularly useful in reconnaissance and stealth operations. Future developments aim to integrate AI modules that will allow the robot to detect threats, adjust its course in real time, and make tactical decisions with minimal input. From high-risk recon to logistical runs in contested zones, the ACW Weasel adds a layer of capability without increasing the risk to personnel. It's not merely a tool, it's a mobile support unit that enhances what soldiers can do on the ground. Moving on, over to China, where military engineers have been testing an unmanned variant of the ZTQ-15 light tank, also known as the Type 15 or VT-5, marking a major leap in ground combat capability. Weighing around 33 to 36 tons, this AI-powered tank is designed for mobility in tough terrains like the high-altitude Tibetan Plateau or the arid deserts of Xinjiang, where heavier main battle tanks struggle. Unlike the manned version, the unmanned ZTQ-15 integrates advanced AI navigation, threat detection, and real-time route optimization, making tactical decisions without waiting for human orders. It still packs its signature 105mm rifled gun with a 3,000-meter firing range, a 12.7mm heavy machine gun, a 40mm automatic grenade launcher, and even supports guided smart missiles. What's more, it's built for survival, equipped with composite armor, optional explosive reactive armor, and NBC, nuclear, biological, chemical, protection systems to handle hostile environments. Powered by a 1,000 horsepower diesel engine, it reaches up to 70 kilometers per hour on roads and up to 450 kilometers of range, extendable to 800 kilometers with fuel drums. Crucially, this tank isn't just a lone wolf. It can operate as part of a coordinated swarm alongside other unmanned tanks and drones, creating layered, adaptive battlefield strategies. Beyond combat, its modular AI systems make it suitable for peacekeeping, area control, or humanitarian missions, reducing crew risks in dangerous zones. Meanwhile, across the Pacific, the United States is pursuing its own vision through DARPA's RACER program, specifically with the development of the RHP platform. This robotic-heavy platform is built to thrive in complex combat scenarios and challenging landscapes, including forests, urban terrain, and mountainous zones. What sets the RHP apart is its blend of rugged hardware and adaptive intelligence. It's equipped with machine learning algorithms that evolve with every mission. As it collects more data from field operations, its ability to recognize patterns, avoid obstacles, and plan better routes improves over time. The platform is modular, giving operators the ability to reconfigure it for specific needs, be it demining, delivering ammunition, laying down temporary infrastructure, or transporting supplies through contested areas. The RHP systems are designed with interoperability in mind. making it easier to link up with aerial drones and other autonomous units for multi-domain operations. Though still in the testing phase, its long-term role is clear. Form the backbone of a fully integrated, unmanned combat network that operates intelligently, communicates across systems, and reduces frontline exposure for human soldiers. The RHP is less about replacing troops and more about enhancing safety, efficiency, and battlefield flexibility. These machines are no longer future concepts. They're active, evolving, and reshaping how wars are fought and peace is maintained. From stealth scouts to AI-controlled tanks, nations are building robotic forces with precision and purpose. Which of these war robots stood out to you the most? Drop your thoughts in the comments below. We'd love to hear your take. If you found this breakdown insightful, go ahead and hit that like button. Subscribe for more updates on military tech, robotics, and the innovations shaping tomorrow's battlefield. Thanks for watching. See you in the next one.